got on the schedule some time for the lablets to give status reports. Since most of you know what's going on, mine will be brief. I'll just review the projects that we have. One's on data-driven model-based decision-making based on quantifiable security. That's the one where the folks are looking at piles of data on activity in networks and building models to detect the presence of intruders before they do bad things, so we can work on cutting them off at the pass before they do bad things. Science of human circumvention of security. There's Jim. He's the guy to talk to on that project on that. Some really interesting stuff on human behavior with respect to security. Hypothesis testing framework for network security. I saw Brighton was here. There's Brighton in the back, so he's leading that project. So making sense of the rules and policies that govern a network so that you can reason about the behavior of that network. Data-driven security models and analysis. That's Bill Sanders' project. So Bill gave some details on what's happening there. Dynamic, static analysis of security metrics for cyber-physical systems. Cheyenne was here. Cheyenne's not here, and he's the one that's leading that project. Interesting stuff there that's combining continuous models based in control theory with discrete models that describe computer systems, and then analyzing the properties of the state spaces that these systems so described can navigate with some metrics about how close they come to places you don't want to be in that state space, bad places. So that's interesting stuff. And then we have a new project just for the remaining time, and that's anonymous messaging. So it's sort of a foundational information theoretic approach to anonymity in messaging. So interesting stuff going on. So one of the things that I have to tell you all, one of the things that we really appreciate about NSA as a customer is your appreciation of our doing things what academics just love to do. And that's give talks, talk about what we're doing, graduate students, write papers. Oh, this is what we love to do. And you love to have us do it. And that's just great because some of our sponsors love us to do other things. So we really appreciate that you like this stuff. And I did a thumbnail sketch from the last quarterly report. And by my count, we had 39 or 40 publications came out just in the last quarter. And citations were there approximately 5. There might have been 6. Where there were papers that were either the best paper or best posters or nominations for these things. So it just gives you a sense of the quality of the stuff that's coming out of this. A couple of notable things in the last quarter is workshops that we sponsored. One of these, again, I would have asked Cheyenne to speak to it. I assumed he was going to be here. That was my bad. But Cheyenne and Gear ran a Science of Security for Cyber-Physical Systems workshop at CTS Week in Vienna this April, and by all accounts, that was a raging success. And so, you know, we're deputizing them to go into the cyber-physical systems community and be evangelists for science of security, and it's resonating. Those are people that are not afraid of mathematics, and I think mathematics is one of the foundational tools that we have for establishing a science of security. And then just last month, we had a Science of Security for Software-Defined Networking workshop in Chicago, and that was interesting as well. Brought a lot of people. I was present for that one. That must have had 50 or 60. You probably know what the number was rigorously. A lot of interesting presentations, talks, discussions about how to approach software-defined networking with the kind of rigor that we like to see in science of security, and more general discussions about how to use software-defined networking to enhance security in general. And finally, we are looking at the remaining budget and understanding that we want to have the money spent by. We're going to ask for a no-cost extension to get us through the end of the semester in the spring, but we will be to zero by then for sure. And so that's just to make sure that we are planning ahead and working with you all to make sure that you get the financial information that you need from us, and that we do what it is that we need to do with that. So that's really all I prepared to talk about on the lablet. Can field any questions that you've got. And if not, we'll pass the token to the next guy. And I'm not sure who the next guy is on the schedule. Jonathan is looking. Okay.
All right. Oh, wow. I'm used to finding an old-fashioned connector. But my laptop has the new one. Amazing. Okay. Except the new one's not working.
Okay, we have HDMI and VGA.
Okay. Well, since this isn't working, maybe we should use... I don't know if I have a plug for HDMI.
We have VGA.
I just always use VGA.
We have
The one that you can rely on working. All right. Sure enough. Okay, good. So I'll talk about the lablet at Carnegie Mellon. We had a number of highlights in the last year. One big part was hosting Hot Sauce 2016 in Pittsburgh. I'll talk about a couple of research progress highlights, and then a more recent workshop was the one on safety for artificial intelligence, which is an emerging area with a lot of interest and overlap with the lablet communities. So Hot Sauce was in Pittsburgh last April. I know many of you were there. Of course, we had the focus on the hard problems of science of security, but more broadly also on scientific methods for security, better ways of gathering data and analysis, experimental methods, mathematical modeling and reasoning. So we had a strong set of reviewers for the program committee and organizing committee. Bill Shirless headed everything up here. His name should be in lights on this page, and somehow he avoided all the mention except the being co-chair of the program committee, but he really led the charge. So we had started with an evening reception at Phipps, which is our botanical conservatory, and had a set of great keynotes. Lori Craner talked about how you go from empirical studies of software and use that to inform public policy. She is now the chief technologist for the FTC. This is a recent thing, but she's having kind of an outsized influence based on good scientific work and usable security and privacy that has come out of the lablet as among other sponsors. So it's great to see that having impact. A number of papers, you can see them. Some other interesting keynotes. Greg Shannon talked about the Federal Cybersecurity Research and Development Strategic Plan. There was a couple of tutorials. This is one by one of our graduate students, but very, very polished presentation on analysis of qualitative data and security. Christos Floutsos talked about some of his work detecting anomaly in large graphs. Another set of papers, and Matt Briggs talked about, gave us a speech on the threat environment. So overall, we had 9 published peer-reviewed papers supporting research from all over, 15 posters in addition, and the 4 keynotes and a couple of tutorials. So I really enjoyed the event. I thought it was packed with kind of a good variety of technical work and demonstrations of how the science of security is having an impact. We have a good set of lablet projects. Here's a matrix of the leaders and topics, we're touching on all the hard problems in one way or another. Definitely an emphasis on composability, but some on just about everything. Some highlights. You've already heard from Travis Sprow yesterday and David today about some of their projects' great work. A couple from other projects. Anupam Datta and Gia have been doing some really interesting work on composition of systems and policies. So they actually can enforce secure object abstractions, the kind of things you would put in a high-level language and enforce in a high-level language typically. But they can actually do it in C or in even restricted versions of assembly code. So it's really neat technology, providing compositional verification of security without sacrificing performance. Something I'm very excited about in one of my projects is some emerging work on immutability. Immutability has a lot of benefits for mathematical reasoning, for security because you can rely on it not changing, and for concurrency, and thus for avoiding kind of the race condition problems that often come up in concurrent systems. We really there's been a lot of work on languages and immutability. We had an interesting study in ICSI where we actually took experienced programmers and interviewed them, and then did some lab studies as well, looking at the usability of existing immutability systems, and also what people need out of it. Some of the key results we got is, first of all, you really need strong semantics to get value out of immutability. So something like const, which in C++, which applies to one particular object or one particular field, is not going to give you as much value as talking about a whole data structure being immutable and everything kind of reachable from it, right? Because if you have the transitive notion of immutability, you can actually package up something and pass it to another thread, and you know that's safe. So we're actually building a lightweight type system that also captures another issue, which is keeping things simple so they're actually usable. And we're right in the middle of both kind of a theoretical analysis of the type system and some user studies with it, and hope to have some more results on that soon. Something exciting this summer is we have an REU program, so a bunch of undergrads coming and visiting us. It's a program that crosses over between the lablet. There's an NSF REU grant, some other projects, but many of the students are in lablet projects. We got some really excellent students, actually over 100 applicants, so it was very competitive. But part of the goal here was actually broadening the pipeline of computing, getting more people involved in computer science, and specifically in software engineering and security. So that's something I'm really excited about. I think that'll pay dividends when we get some of those students coming back into the community as grad students, and so on. I already mentioned other community impact. Lori as chief technologist. She's actually still around at CMU, so she's participating in her in the lablet and in advising her students. We have some keynotes, some other conferences we've organized. Let me talk about one notable event that just happened last month. This is the SAFE Artificial Intelligence Workshop. There's been scary stories about robots taking over the world for a very long time. Interesting scientific speculation, of course, from those like Isaac Asimov, who talked about what should the laws of robotics be for safety. This has been a theme in the literature for a long time. We're actually discussing it from a scientific point of view now. And so there was a workshop co-sponsored by the SOS Lablets and organized along with the White House Office of Science and Technology Policy. And the basic idea is, how can we advance engineering of artificial intelligence systems with safety and security systems integrated from the outset, right? How can we how can we, you could call it the science of building secure AI, safe and secure AI systems. And I think that is a very big challenge. So there's a lot of interesting connections. We had you can see a few of the names here who were involved in offering perspectives and in some cases very detailed focus topics within this area. But there were a number of themes, looking at, first of all, what are the applications of AI? What are the safety requirements we want from those applications? What are the mathematical models and reasoning we use to apply in other areas, and how can they be applied to artificial intelligence? What are the kinds of systems and safety engineering practices that we follow, and can we use those to build artificial intelligence systems? So it was definitely an interesting exchange with a lot of expertise coming from both the safety community, the verification community, and the AI community together to look at this issue. Here's just some of the questions that were examined. What are the mission contexts in which we're doing AI? The dimensionality of safety. This is really about if you want to reason about safety, what are the concerns that you're concerned about, right? If you want to formally model things to assure some notion of safety, what's the boundary between the part of the world you model and the part that you don't? So that's something that's not always been clear in, it's challenging in every setting, but I think in artificial intelligence, when it's often not, it may not be clear exactly how the AI algorithms do the jobs that they're doing. It's even more challenging to do this kind of reasoning. So that actually leads to another issue, which is how do we pierce the opacity of modern systems, right? How do we understand what these AI systems are really doing so that we can, impose verification ideas onto that process? Modeling of various things. How do we choose our models? A classic problem, but something that has new applications in AI and actually old connections with AI, right? When we do theorem proving, we think of that as verification today, but it started out as search for proofs, and search is classic AI. So the connections in these fields really go way back, but we're now looking at the intersection in new kinds of ways. So finally, systems engineering. Are there architectural features that we can leverage as we build AI systems to provide safety? What about other kinds of practices? How can we integrate those? David, I know you were at a couple of sessions. Do you have anything to add?
No, I think you covered it pretty well, but I was impressed at the very broad presentation. Government, industry, it was really a very interesting coming together of communities there. It'd be nice to see if that continues in that way.
Yeah.
Any takeaways from it? Any conclusions?
There's a lot of good work going on, but not a lot of crosstalk as far as I can tell.
Yeah, my sense was this was a way of getting people in the same room and to understand each other, and it's probably going to take more back and forths before you get to something that you could really call a conclusion. But the first step is speaking the same language and recognizing there are interesting problems in this intersection. So that is probably the main takeaway.
I thought one of the issues that was interesting was the modeling and how much do you trust the models when you start turning things over to machines.
Right.
Interesting discussion.
Right, and I think there's an interesting...
Self-driving cars was the particular topic.
Yeah, there's an interesting... that relates to the opacity of the artificial intelligence methods, right? In many modern methods, there are statistical roots to them, and we don't understand them from a kind of traditional logical perspective that we usually take in verification. So we need to find new ways of reasoning about that.
You want to go first, Dave?
Go ahead. So an interesting statement that I've heard from people in government, people in industry, is that even if AI basic approaches for making certain decisions or controlling or whatever it might be work, there's a real fear, and this is important, I'll say this, there's a real fear because we don't know why they work. So we have a deep learning approach that a person might use a deep learning network to come up with a response algorithm, but then would somehow try to codify that response algorithm that's derived in a deterministic way. So even if it might not be quite as good, we know what its bounds are, and we know when it works, at least this is the argument, when it works and when it doesn't work. What was that addressed, and what was the, I've heard this said in the security context from U.S. government people that we will not use deep learning approaches to implement a resiliency response because it might surprise us someday. Do something we don't know is in the realm of what it might be. Was that discussed, and what was the opinion?
I think the approach is fit into two categories. One was after the fact. I've got my system, how would I test it to, for example, detect biases? The second one was, what can you do in the process, perhaps reducing the efficiency of your learning but improving the explainability. So you build into the mechanism a little bit more self-scrutiny into what's going on. That's very general, and it was instantiated in a couple ways. But I think, for my money, the best talk in terms of clarifying the field I don't know too well was John Launchberry, who talked about the three waves of AI. The first being manual, where we build expert systems and we code it. The second being statistical, which is what a lot of people are using today. In his view, the third one is contextual adaptive systems that have explanatory capabilities. So for him, that's the hard problem that people really should be working on. Garment perspective.
So that fits in with this worry,
Yeah.
So when the robot hits you over the head, it can explain why.
Yeah. Or at least you need to understand why.
Yeah, so
Suppose if you knew why, maybe I don't know. Sorry.
no, we should. So we should probably move on to the next report. But I think I think this is a really interesting emerging area that in which there could be more engagement between the lablet community and particularly for security-focused interests, right? AI for security. So I'll with that I'll pass it on, and Uninder.
Try HTML.
You want to do HTML?
Yeah, it usually works. Is this two? Let's try two. Hi everyone. Thanks for sticking around till nearly the end. So I decided to give a summary that mainly highlights. I'll just talk about a few projects and conclude with a discussion of some community aspects. I won't talk about every project, and I wouldn't have the statistics on papers and so forth because those are already uploaded on the VO. So one of our projects is led by psychologists. Chris Mahon is a colleague of mine, and Murphy Hill is a computer scientist helping him, and the student Olga Zelinska. So what these guys have been talking about is studies on social engineering and susceptibility. And one thing they point out as interesting in their work is that they don't just model users, they also model attackers. So they looked at attacks, like phishing attacks in particular, like about 900 emails or so, and they discovered that they analyzed those through a few users, and they achieved high inter-rater agreements and so on. And what they discovered was that the attackers are using apparently using Cialdini's persuasion theory. So they're using some of the elements highlighted by Cialdini, and in particular the newer ones. They talk about commitment consistency and scarcity. Commitment consistency is like a sales tactic where you get people to agree to something early on, and then you sort of hold them to their word. You sort of suck them in, and then you get them to stick on till later. They have also conducted some user studies, and in the user studies they discovered that nearly everybody is susceptible to phishing at some level or the other. They also try to model, understand the cognitive capacities of users and how they relate to susceptibility. Much as you would expect that when users have higher cognition, attention, and working memory, they're less susceptible. The other thing, the more noticeable one, was that people who are naturally suspicious, sort of, who have these personalities where they are either reserved and in being able to control their emotions, or they are just distrustful, or they have very recently been bitten. So those people are much less likely to fall for it again. So that's a stronger effect that they discovered. And now they're going to look at how these various things relate, how these personality profiles relate to susceptibility. Okay. Another project is by Laurie Williams and a student Chris Tyson, and this is a sort of a quick summary of it. So what they're trying to do is what they call the attack surface approximation, and the intuition that they have is that there's a lot of code around, but instead of looking at all the code, if you could look at stack traces, so where a failure has already occurred, then maybe that failure would be indicative of also vulnerability. So it's not just like a functional failure, as it were, but maybe a problem with vulnerability. And they've collaborated some with people at Microsoft Research. So there are things like this, that approximately half the code features on some stack trace or the other. But if they were to look for vulnerability fixes, then a large percentage of that code will show up on stack traces. So in a way, what they're hoping is that they can use it as a way to guide software analysis, to vulnerability analysis. So they can guide it to improve the efficiency and maybe find the more likely breaking points.
Does that 94.8% mean before or after the vulnerability was fixed?
I think they looked at the code bases that they have. So the 48% is of the code would have occurred on some stack trace.
48% of all the Windows code.
Yeah, Windows 8. Yeah.
Right, appeared on something except that 94.8% of the code with fixes.
So if they look at the code that had to be fixed repeatedly, then that code showed up on some stack traces in the
I'm wondering if that's code continued to show up after the vulnerability was fixed, or if it's pre or post.
I took it to mean that this was just things that had been fixed. So, but not that they showed up after they were fixed, but that they were fixed. Another project, this is one we started in January, so this is by my colleague Jessica Stadden, and working with her was a GRA, actually one of my former students, Pradeep Murukanaya. So what they addressed was the problem of coming up with a way, like a community tool, as it were, to support research into privacy. And in particular, there are all kinds of security incidents databases, but there's hardly anything that pertains to privacy. Now, to some extent, these two things overlap, but they often don't overlap all that well. And what they discovered was that there are many privacy incidents which are never a security incident, and so on. So they started to develop a privacy incidents database. They have been, since January, they have, I guess, developed a conceptual model. They are putting in some incidents by hand. What they started to do then was develop tools to do automated analysis of public media. I think in particular they looked at things like reports in the New York Times, but things of that nature. They want to get to public media, and then in that, if something, so the idea is that some incidents should be reported publicly, and they can add them. And one of the things they're trying to do with the tools is that they just look at news reports that have the word privacy in them, and then they have to figure out if that report signifies a privacy incident or is just some other reference to privacy. So they're developing tools which should do that well. And they have a few hundred or several hundred incidents that are currently recorded. So one more project. This one is on policy composition. This is from Purdue University, who are one of our subcontractors. The last two authors are the faculty members, Ming-Hui Lee and Robert Proctor. The others, I presume, are the students. The challenge they address is that there are often many policy misconfigurations, and they arise because of policies being configured in two places which interact in a way that the authors do not anticipate. So one example they give is that there may be one place where you grant a program or an app a write permission, another place where you grant it open read permission, and you pull these together. Now this program is able to change or delete a file which we never have intended originally. So they had developed a tool, because these policies are not in one place, so they developed a tool to extract these policies, discover these kinds of implied or implicit compositions, and they're trying to figure out how to deal with such cases where the composition is granting more privileges, than was intended. And of course, the risk is that if you go and mess with one of these, then you might break an app that's already working. So that's what they're working with, and this is in collaboration with Samsung. Okay, so here's a project that Oscar Kafala, who's our postdoc sitting there, Neeraj Meri, a student of mine, and I've been working on. It's just recently appearing. And this is because it's Oscar, I also have access to the pictures for this. It's the only one with the picture. So the basic motivation in this work is that we've been trying to formalize socio-technical systems, and we just want to, what happens in a lot of traditional software engineering methodologies is that they do recognize that there's a social layer, but then they compile it out when they come to the software layer. And what we are trying to do is keep the social tier and the technical tier as sort of available at runtime to reason about formally. So we're trying to capture those. So our stakeholders have some requirements. They describe a system in terms of the norms which regulate interactions here, in some software mechanisms which determine how these functional components compute, and then some assumptions under which those requirements should be met. And an example of what we have done is that we have an approach to refine STS specifications. So this example is derived from something that comes out of HIPAA, that in the case of a federal emergency, hospital and all have different treatment of information sharing for patients, and so things of that broad. I think this is just about emergencies, it's not about disasters. So this particular one is just about emergencies. Each of these blobs is one specification of a socio-technical system. Very briefly, I'll talk about this one. Very briefly, what it's saying is it's describing some assumptions. So like in this case, the assumption is that if there's a power failure, then you cannot be logged in at the time because the computer is off. So we have an assumption. We have some notion of mechanisms. In this case, the mechanism is that you can obtain consent from a patient. And then there are these normative requirements which say, who's authorized to do what, who's committed to doing what, who's prohibited from what. And so from each block, we start with some authorization and prohibitions. We discover that we can't satisfy all of our requirements, so these ours are the requirements. And we say, okay, in order to satisfy a requirement, let's apply a design pattern, modify the norm somewhat. We still can't satisfy them, modify the norm some more, and so gradually work our way up to a solution. We also adapted this work, which is appearing next in September, which deals with modeling misuses. So we want to understand not just security flaws, but users doing things they should not be doing. And so if they violate a commitment or a prohibition, then it's often a violation by a user. So we are looking at that. And our broader goal is to have a formal theory that incorporates the human element on par with the technical element, as opposed to leaving the human element purely to the psychological studies, to put it into the computational model. Okay, so in that case, let me go to the last slide I have, which is on community engagement. This quarter, like the previous years, we've organized a summer research workshop, which is focused on doing good science. It's about analyzing papers that have appeared in security conferences. It's about scientific methodology in the abstract sense, and then about determining if a certain paper would meet our expectations of what it means to be good science. Even though it's obviously we're looking at papers that have appeared in the best venues that you can think of. So at some level they are good contributions, but they may not always be. They may not always have the features that you're looking for in terms of scientific research being reproducible and so on. So we dwell on that a bit, and then in this particular workshop, we also had an industry panel with 5 participants from leading sort of industries that pertain to security. I would say one of them specifically on cybersecurity from IBM's security group, and the others from more application domains. 3 of them from application domains. And we continue to have ongoing interactions with industry. We also have interactions with NSA. Besides the people here, we interact with the Laboratory for Analytic Sciences, which is based on our campus. So their members come to our meetings from time to time, and especially the industry, the workshops that we organize. They sometimes ask us for papers and findings that they want to apply in their high site. So we don't know what exactly they do, but they do ask for what we are doing, and they take it up. We also had Brad Martin stop by, I think partly because of LAS. This summer we've had a smallish REU thing going, which is, I think overall it's large but smallish in pertaining to the security aspects of it. We do have female and minority students involved in that effort. As a plug, we have this industry day coming up in about 2.5 months. This will involve a bunch of Pecha Kucha presentations by students. If you haven't encountered Pecha Kucha before, it's a Japanese architectural kind of a theme for giving presentations in which the slides are put on auto forward at 20 seconds. So you get 20 seconds, you get 20 slides, and they just scroll on. So either you say, if the idea is you should not be saying too many words, but for architects you put up a picture and you show this is my building and this is his building. But computer scientists, of course, speak up a bit. But the idea is it makes for very dynamic presentations, which had to be prepared over. It takes about a month to prepare them, to distill everything down to 400 seconds. And then we have industry presentations. Industry guys usually don't do the 20 by 20. They give them more time. So if any of you is able to attend, that'd be great. That's all I have. Okay. All right, now I'll move away for Jonathan.